Hello, this is Jim McKeeth, Developer Evangelist and Engineer for Embarcadero Technologies, and welcome to this Delphi Developer Skill Sprint for January 26th, 2016 on practical data compression and decompression. Make sure you grab that link down there at the bottom, embt.co/sprint-compression, which is where you'll find replays, more information, downloads, etc. for this skill sprint. This skill sprint is going to work across all platforms and all languages. So this applies to everybody. Assuming you're using 10 Seattle, your mileage may vary for older versions. Parts of it are Windows specific, which I'll point those out, but most of this is across multiple platforms. So we're going to cover. Some of it we'll cover in more detail with examples. Some of it I'll just point you to more information where you can figure out things and get going on your own. So a little background on compression. Now there's two types of compression, generally speaking. There's lossy compression and lossless compression. Lossless compression is used for data compression because you don't want to give up any data. Lossy compression is used for media like pictures and audio and video. And there it gives up a little bit of the data because the idea is it's data that you wouldn't notice or that won't significantly reduce the viewing or enjoyment experience of that media. So we're talking about lossless compression today. The zip file format, which is one of the first, it wasn't one of the first ones, one of the first most popular ones, or first on Windows, or DOS actually, PKZip, was developed by Philip Katz, and it used different compression options, but the most popular option was deflate. And deflate was based on Limpel-Ziv Welch. Now Limpel-Ziv, they actually, if I remember correctly, they had two papers they wrote back in 1977, 1978 on compression. Most compressions are based on those original two papers, 77 and 78. So you'll see a lot of things that'll be LZ something, and that'll be the compression. It'll be based on, basically took their original papers, built on that, and came up with a new compression format. So LZW is the basis for the Unix compress and for the compression inside GIF images. Now, later it was found that there was patent encumbrance on that implementation. So GZIP was an open alternative implementation to compress to avoid the patents, and it was optimized for speed. Now, the idea was it could open and compress and decompress the same data, but it was a free alternative. Later on, the ZLib library was developed as a wrapper around to both deflate and gzip. So the difference was gzip has some headers on it, whereas deflate is just raw compressed data. ZLib also supports PNG images, which take advantage of the deflate compression used in ZLib. Okay, so that's kind of a brief overview of compression formats. If you want more information, Mark Adler wrote a great Stack Overflow post about this, or you can check out the Wikipedia entry for data compression. So there's a few other alternatives besides the main zip and deflate. RAR uses Limpel-Ziv Store Zamansky. LZSS actually uses some of its own compression formats as well. 7-Zip, which is the newest and one of the more popular ones right now. RAR's been around for quite a while, but 7-Zip is very, very popular. It's free. Uses the Limpel-Ziv Markov chains, LZMA. One note is both 7-Zip and RAR support all the other common file formats as well. 7-Zip will, for example, support RAR. CAB, which is Microsoft's preferred one, or at least it was, I'm not sure if it still is or not, uses deflate LZ77, which is the Limpel-Ziv 1977 paper with Huffman encoding. And then TAR. Now, TAR is not actually in a compressed file format. It's a tape archive. And what it does is it joins a bunch of files together so that they can then be compressed. So one note about archive files is if you take the original zip file, what it did is it compressed each file with the preferred compression format, which I said was usually deflate. And then it puts those all together into one big archive with a header that says, this is the files I contained. This is where they're at. This is how big they were, etc. All this metadata about it. So when you open a zip file in a zip viewer, it will give you a little window that shows you, checksums and all these different values about these files. So that's an archive file that takes advantage of compression within the archive file. Now, when archive files, you can talk about archive files. For example, you have the tar file, which is a bunch of files that have been joined together, which can then be compressed. So sometimes on like Linux or Unix, you'll see tar.gz, which would be a tar file, which is a bundle of files that has then been compressed with gzip. A tar is an example of a solid archive, which is where you combine multiple files together and then compress them, which is different than a regular archive, like the traditional zip file, where you compress each of the files individually and then combine them together. Now, the difference is that the solid archives take more memory or take more time because it builds a much larger compression dictionary, and that gives it the ability to actually compress it better. For more information on archive format, you can check out that Wikipedia link there. So HTTP compression, they call it encoding. You can specify in your request, you say accept encoding, and then in the response, it'll say content encoding, and that'll tell you what it was encoded as. So the idea is that you say to the server, I will accept these types of encoding, and the server says, this is the type of encoding you get. Usually it respects that. It doesn't have to, though. Sometimes you might say, I will accept gzip and deflate, and it will say, I got nothing for you. Or other times you'll say, give it to me in plain text by specifying an empty accept encoding. And for example, in Stack Overflow's case, it always gives you gzip back. So the two most common are gzip and deflate, which in accept encoding, it's accept encoding gzip, deflate, and that would give you one of those two, whichever the server preferred, which will usually be gzip. There's a number of other encodings that are also possible. I will point out the one at the end there, Brotilli, which is named of Swedish pastry, I believe, is actually a new compression format that was developed, I think, by Google. It's been implemented in Firefox, and Google's planning to implement it in Chromium and Chrome. And it's a new compression format that is specifically built around HTTP compression. What it does differently is they've analyzed a bunch of HTML and looked at it and found common things. So if you think about HTML, it has tags, and they said, oh, all these tags are common. So they've built up this dictionary of all these common tags. And what they do is they pre-initialize the compression algorithm with this dictionary of tags so that it can achieve better compression when it's compressing HTML. Otherwise, it's based on the same compression deflate. Well, it's a LimpleZiv variant. I don't remember exactly what implementation it is. And so it's just as fast, and for non-HTML, it compresses it just the same. But when it comes to HTML and a few other data types, it's over 20% or about 20% more effective, better compression. So that's pretty cool. So we might see more of that in the future, the Brotilli compression format or encoding format. So keep an eye out for that. So your compression library options, we're going to talk about pre-installed. You have System.ZLib and System.Zip, as well as Indy's TID compressor zlib. System.ZLib is low level, allows you to compress and decompress streams of data or strings or whatever, any sort of bits of data you want to compress. Now, if you want to actually put bits of data into a zip file that can be opened by other file formats, that's when you want to use System.Zip. It has a tzip file in there. Now, you could use the System.ZLib, compress a stream of data, and save it to a file, but it wouldn't be a zip file. It wouldn't have that metadata in there that describes the zip file. That's what System.Zip does with the tzip file. So with that, you're able to create zip files, add files to it, remove files, and otherwise manage zip files. The Indy's TID compressor zlib has some compression methods specifically focused for data transfer, for like HTTP compression, FTP compression, etc. And then via GetIt, we have a couple options. You have Abbrevia, which is available for all platforms. It supports a wide variety of compressions beyond just the zlib, gzip, deflate, etc., and has some great test suites, so you can see the examples of how it's used. Then JEDI JCL has the JCL compression library. It's Windows only, and it actually adds the ability to work with 7-zip files. So that's worth checking out as well if you want to deal with 7-zip files. Okay, let's take a look at doing some compression, real-world practical data compression and decompression. This first sample shows you how to use the System.Zlib compression library. So what I've done is I've created a method here, test compression, and I just pass in the 4 different compression levels so you can see the difference between the different compression levels. I guess I could have tested them for speed as well, but I didn't. None will be the fastest, followed by fastest. Default will be a little slower, and max will be a little slower. The reality is this is still going to be pretty fast, but if you're dealing with a huge amount of data and you know it's not going to compress very well, then you might try using fastest. And so that's just something you can use on your own. But this is the method here I'm going to show you here. And so what we're going to do here is we have a uncompressed string stream. So this is going to read the string of text in here from this memo and then compress that. And so we're using a string stream to read that in. And then we're going to, when we get the compressed data, we're going to store it in a memory stream. Now to do our compressing and our decompressing, we're using the T-compress stream and the T-decompression stream. Now these are both defined in System.Zlib. Now one note here, they're defined as TZ compression stream and TZ decompression stream, but we have an alias for that of T compression stream. And that's just the TZ compression stream is the old name, T compression stream is the new name. You can use whichever one you want. That's okay. One note also in here is that we do have the ability to use the Z compress string or Z compress stream and the decompress alternatives to these to just compress it without constructing an object. It does the same thing, just with it's a procedural call instead of an object that you would call the method on. So we're going to construct our streams here. So there's our string stream and our memory stream. And then we construct our compression stream. We tell it the compression level, which are getting passed into us, which you saw those earlier. And then the destination. So it's going to be basically when you write to this L compress, it's going to output to this L compressed. Okay. So we take L uncompressed, which is our string stream. We're going to put that memo in it. And then we're going to copy from L uncompressed into L compressed, which is our compressor. And it's going to, and we're going to tell it how much we want to write, which is going to be the whole length of it. And then we want to free and nil L compress. Now it's important that you free and nil uncompress because the L uncompressed doesn't get flushed out until you do this. So if you free L uncompressed first, then free and nil L compress. So remember, this is the destination. It may not have written everything out yet. And then you'll get an error saying, well, I couldn't write to L uncompressed because it's not there anymore. So free and nil L compress first, and that flushes the buffer. Okay, so at this point, we have the data in L uncompressed. And so now we're going to decompress it. So if we wanted to persist this to disk, we could save L uncompressed to disk. We could use the file stream instead, saved it to disk, or we could have streamed it over the wire, sent it through a socket or whatever we want to do with this compressed data. So it's compressed, it's going to take up less space, it's going to transmit faster. So now this is how we do the decompression though. So the purpose of this algorithm or this procedure is just to compress it, show you how to compress it, show you how to decompress it. Then it gives you some information so you can see that it worked and see the size differences. So we're going to create our decompression stream. And here I call it with the Z on there. I guess I could take that off and use the new name. So we're fancy. And we specify the destination, which is L compressed. And, that specify the source. Sorry. Let me look at that. Yeah, specify the source. And we're going to clear our L uncompressed, which originally had the string in it, but we're going to clear it out because we're writing to it again. And then we're going to say L uncompressed, copy from L compress and the size of L compress. Okay, so however big that was, we're going to copy that many bytes into our uncompressed, L uncompressed. Okay, and then we're going to take that data string and write it out to memo2.txt. And at this point here, we're just going to log the data just so we can see what the sizes were and what the compression at the different compression level. And then we do a little hash in order to verify that the decompressed and compressed data were the same, which they should be. So this is not really a unit test. It's more of just a little test app. I'm sure there's a unit test somewhere that tests this, but for our purposes, it'll demonstrate how it works so you can see it working and see its performance. So let's go ahead and run this. And I'll hit compress. And so we see here the different compression levels. Compressed none, we'll see that the size actually gets bigger. And that's because it adds 1 byte in there to show that it's compressed. Well, it's compressed. I'm using the air quotes there because it's not actually compressed, but it's in that new format. And then we decompress it and the size is the same. So the ratio is 1.0 and the hashes are the same. So fastest we see here, it's a ratio of 0.35, so less than half of its size. And we see here's the original size and there's the compressed size. And we'll see that the other ones stay about the same ratio. And the reason is because this isn't very much data. So if we want to give it more data to work with, so I'm just going to copy all this to the clipboard. Okay, so I've just pasted that a whole bunch of times in there, and then we'll go ahead and run this again. So it takes a little bit longer here to run this time. Not much longer, still pretty fast. So we'll see here that none, it added a few extra bytes on here. And then here, in the ratio stayed 1. But then fastest, look at that, it dropped down to 0.03. Now, one reality here is one of the ways compression works is by looking at duplication, and it said, you just duplicated the same code or the same text a whole bunch of times in here. So it's going to get really, really good compression on that. But we see here that this one, default and max are smaller than fastest in this case, significantly smaller, a third of the size. So there you go. That's a little example of this. If you want to pull some other larger data in here, just do this. We'll go in here, System.ZLib. Let's copy that. Aha. See, this is big and not just a bunch of copying and pasting over and over again. And we'll compress that. Okay, so we'll see 0.29, 0.23, 0.23. So this one's actually just a hair smaller than the default one, maxes. Anyway, there you go. There is the performance of System.ZLib for compressing data. So this next example here is showing how to decompress the REST response. So I mentioned earlier that Stack Overflow always compresses. So here we're pointing to API.Stack Exchange, the Stack Overflow API, and we're going to get all the questions tagged Delphi. Now, I'll go ahead in here. I actually have it. First request. Take that off right now. Okay, so I'll run this here first, and you'll see what happens if we try and go to Stack Exchange's API. Hit the button. It says response content is not valid JSON. You're like, what? So we come here and say execute request, and we get the same error here in IDE. Now, if we look at our request, inspect encoding, let's take that off there. Execute. Still get the same error message. But if we look at response content encoding is gzip. So it's like, no, we don't want gzip. Let's clear that off there. And we're going to run this again. Execute. Same error message. We come back and it says content encoding gzip. So what's happening here is even though we're saying we don't accept any encoding, the server always is going to send us gzip. They have an article up on the website that says, okay, face it, everybody supports gzip. We're just going to send you gzip. It saves bandwidth. I understand their philosophy, their point of view, but it's kind of annoying when you're not expecting gzip. So how do we deal with that gzipped? So on the request, there's an event here on after execute, and I made a method here called decode REST response. And you just pass in your REST response to that here, to that. And then here's the REST decompressed. And one thing we're doing here is we're doing the protected mode workaround here. So we have a protected REST response. And what that does is it gives us the ability to set the content of the REST response. So typically you're not able to do that directly. It's only able to set the content of the REST response by the REST request, sets the value of the REST response. But we're working around that because we're changing the value of the REST response to decompress it. So what happens in here is, first of all, we look to see if the content encoding is nothing, then we just exit. There's nothing for us to do. But then what we do is we look to see, we get the data out of the REST response, the raw bytes, into a stream here called L compressed, which is a memory stream. And then we create an ND compressor zlib, and we look at the content encoding. If it's gzip, which is, in the case of Stack Overflow, it's always gzip and is the most prevalent compression type, encoding type on the web, then we call decompress gzip stream, and we pass it in the compress stream, and then the destination decompress stream. Otherwise, we check to see if it's deflate, which is the second most common encoding type, compression type on the web. And if it is, we do decompress HTTP deflate, and again, passing in the two streams. Otherwise, we raise an error and say unrecognized content encoding, and then we tell what it was. So according to what I've read, we probably will never hit this unless the server is just really goofy, or maybe it's that new Bertelli, I can't remember what it's called now, the new compression one that Google's developed that's based on the Swedish pastry. And then we'll have to come and add a third line in here for that. Although if we're not asking for it, we shouldn't get that one, at least for the foreseeable future. Okay, and then once we've got that decompressed string stream, then we use our protected mode workaround here on the REST response to set the content, and we put the data set, the data string in there, and then clean everything up. So let's take a look at this in action. So we'll hit the button, and boom, look at that. We've got a bunch of questions tagged with Delphi. Here's one on MD5 cryptography and hashes. That sounds like fun. We should go out and read that one. Here's the original JSON there. I should put word drop on that memo, but there you go. That's it. It works fine. So this will be available on the download link, and you can take advantage of this to decompress your JSON streams for reading the Stack Overflow API. So these are the tests for Abbrevia. You can come in here and find the tests. So let's say you wanted to see how to do, here we go, zipper tests. So first of all, this is I think all these tests are written by Robert Love, one of our fabulous MVPs. So thanks to Robert for that. And you can come in here and come and look and find, okay, where do I want to, so here's, this does a tar.gz regular zip file. So we see this just is going to create a zip file. That's all there is right there. Pretty straightforward. Pretty simple test there. And then here we got some more complex tests down here. So you can come down, look for what is you're trying to accomplish, and you can probably find a test that does that for you. And you can run all the tests to see that they're running correctly. So they're just going and doing a lot of compression at this point, so it slows down a little bit. And we're done. So very cool. You can check that out. There's the folder. Then you're going to find the catalog repository, Abbrevia-10.0/tests. And then here is the JCL compression library, which this goes through and explains the class hierarchy. And then you can find the classes you're looking for and call the methods on there. I'm not going to go ahead and run this one, but like I said, this one is Windows only, whereas this one should work across all platforms, Abbrevia. If you would like more information, you can find examples of using the System.ZLib's tcompress and tdecompress there. There's both Delphi and C++ builder examples. Then if you want to take advantage of the System.Zip.tzip file, there's the documentation on it for you available there. Abbrevia, here's a link to where you can view the tests, the unit test online. Abbrevia is installed via GetIt, and once installed, it's put in that code repository folder that you see there. The code repository is in your user directory, and then whatever that code repository folder is, the Abbrevia-10.0/tests is where you can find those tests to see how all the functionality and how they work. Those tests were developed by Robert Love, one of our fabulous MVPs. Thank you, Robert, for that. And then the JCL compression library, which is also installed via GetIt as part of the JEDI JCL. You can browse that on GitHub, or you can also find jclcompression.pass in your BDS code in your catalog repository as well once you've installed it via GetIt. All these links and more are available at embt.co/sprint-compression. Give me a brief moment to tell you about this limited time special offer. All 10 Seattle registered users get the bonus pack, which includes the new Object Pascal Handbook by Marco Cantu. This essential language reference is a modern language guide that includes new features of the language and the core runtime library, a must-have for any Delphi developer. Also get the Binder Converter Basic. It handles the heavy lifting when converting existing VCL applications into FireMonkey applications, so you can start taking advantage of multi-device development right away. And the Premium Style Pack includes premium styles for VCL and FireMonkey to make your application look great on every platform. For more information on these special offers, or to find out what the current offers are, please visit www.embarcadero.com/radoffer. Next time is developing REST servers from scratch with Craig Chapman. He's one of our SCs. Tuesday will be Delphi, which is the 2nd of February, and C++ Builders on Thursday, the 4th of February. All those dates and times are based on San Francisco time, so check timeanddate.com or whatever mechanism you use to check time zones and make sure those are correct. If you want to see the full schedule or replays, check out the link you see there in the middle. And that's it. Now it's time for Q&A. We've already got a few questions queued up here. So Peter's asking what all versions of Delphi that support this. I tested this on 10 Seattle. They come through the GetIt on 10 Seattle. The 7-zip System.ZLib, I'm sorry, not 7, System.ZLib was added, I think, at XE8. I'm not positive if it was XE8 or Seattle that was added in. The ND compression has been around for a while. I'm going to say Delphi 7, but the rest components were added in XE6, XE5, XE6, somewhere around there. Then the Abbrevia probably supports Delphi 7 or newer. I don't know. I haven't tested it in a long time. I know it was originally released way back then, but it's been updated a lot. So it's possible at some point they said, you know what, it's no longer going to support Delphi 7, so they can take advantage of all the great new language features that are available in for Unicode and stuff like that. So there's a lot of great new language features. So it's possible Delphi 7 may have fallen off the support standard. You'd have to check out TurboPack.net, and you maybe can find some information about what versions are supported from there. So beyond that, Peter, let me know more specifically what you're referring to by this. I can tell you maybe what version of Delphi that supported that. So Arnie's asking what compression is used to convert or compress an SVG, a scalable vector graphic, into an SVGZ. I'm looking real quick. It looks like it's gzip. Yeah, it's gzip. So you should be able to decompress that with gzip decompression. System.ZLib should be able to decompress that. Since it's a single file, it's most likely just a gzip string that's been persisted to disk and doesn't have any header information on there, additional header information on there. So what I'm referring to there is a zip file is a bunch of deflated streams, gzip compressed streams that have been included, put together with header information and a directory that explains what all the files are in there. So if you just take a zip file and try and run it through the gzip stream decompress, system.zip decompress, it won't work because
that's a stream decompression. It decompresses a compressed stream, whereas a zip file has a lot of other data in there, defining what files are in it. Now, that's where you'd want to use Abbrevia or JCL compression, because those have the additional functionality to understand the header information. Okay, but I'm suspecting that SVGZ is just a gzip stream. So I would suggest take a look at documentation. Wikipedia's got some information on it, it looks like. Stack Overflow's got some information on it, and see what it says. I'm pretty sure it's probably just a gzip stream, and you should be able to just run it through System.ZLib and decompress it. It would seem that compression and decompression would generally be a good candidate for parallel processing. Possibly. I would probably. There are, as far as the algorithm itself, there are some ways you can optimize the algorithm itself for a single stream. But if you're dealing with multiple streams, like for example, you're building a zip file, if you're going to compress a bunch of files and you have 8 cores, then sure, spin up 8 different compression streams, compress all those files, and then when you're done, combine them together into a single archive. So yeah, there's lots of opportunities to do that for improved performance. And also, you'd want to use a background process in order to deal with keep your UI from locking up when you're doing the compression as well, in order to improve responsiveness. So great opportunities to use gzip or parallel processing with compression. Okay, so what's the current version of Abbrevia? And I'll go into Rad Studio 10 Seattle, and I'll click on Get It, and it says 10.0 is the version that's available for download.
Yeah, just go into the Get It package manager. It's easy. You can hover, it gives you more information when you hover over it. Last updated December 2015. If you hover over the icon in the Get It manager, you'll see it. And all of them list version numbers when you look at them or hover over them.
So the question of if the examples that I talked about work with audio or images. So as I alluded to at the beginning, audio and images are typically encoded with a lossy compression, which would remove, it degrades the media in a way that doesn't significantly degrade your ability to enjoy it, I guess is the way to describe it. So for audio, it tries to take out frequencies that are not, can't be heard by the human ear, for example. For photographs, it looks for pixels that are adjacent to each other that are very similar and makes them the same so that it can compress them with run length encoding, etc. So you can use a lossless compression on media, but it doesn't get as good a performance because it doesn't have those optimizations designed around media. So you can use what we showed today was lossless compression, it's data compression. Because in data, you don't want to optimize out data in order to increase your effectiveness of your compression. Because the most important thing for data compression is that you can uncompress it and get exactly the same data back. Whereas media, the most important thing is maximum compressibility with still having good being relative media quality. So yes, you could use it as a lossless compression for media. So for example, let's say you want to stream some a picture, but you want to keep it perfect, you could run it through gzip and compress it. Now, I would suggest that you do a test scenario and test compressing whatever you're going to compress and see if it's producing a significant amount of compression. Because if it's not, then let's say it comes out at 0.9 ratio, then you're wasting your time. Don't bother unless you really need that bandwidth, because you're going to take a big hit in performance when it's doing the compression or decompression on a large amount of data. So your mileage may vary, I guess is a good way to describe that. Okay, so apparently Peter was asking about the REST components functionality. Yeah, the REST stuff is so incredibly cool, so incredibly powerful. I actually have a blog post up on Delphi.org where I show how to build a REST client for a web-based REST server and then deploy it to all 4 platforms both Android and iOS in 5 minutes. And I do that demo when I'm talking to people about Delphi development, and it just blows them away because I was just talking to a guy that was a C# developer, been doing C# for years, had a huge C# shop, and then wanted to move to mobile, and they were like, "Oh, we'll just use Xamarin." And he started working with Xamarin. He's like, "This is going to take me forever to build just a simple REST client, which is going to be used proof of concept." And I'm like, "I could do that in 5 minutes." He's like, "No way." Sure enough, pull it out, build it in 5 minutes. So yeah, those REST compliance are incredibly powerful with Delphi. So Tom is saying, with my experience, lossless compression with, say, audio is next to worthless. Different tool, different purposes. Yeah, I would agree, Tom. Most likely you're going to see for audio compression or image compression, for like a photograph, if you try and use this lossless compression, the gzip and deflate, stuff like that we showed, you're going to see very, very little compression. And that's because the lossy compressions optimize it so that they can produce a better compression.
Hey, Jim, I can't wait to get a copy of that Stack Overflow API program. I have some ideas for a couple apps that I want to build using the same kind of technology. That'll be cool.
Yeah, so I just posted the link to the decompression unit that you can add, and it has instructions on how to add it, and then I'll have the download link for the full sample here available shortly. So Abbrevia is available through GetIt, and I think on the page there, let me look. Yeah, there's a link so you can see the Abbrevia test suite, a link to the test suite on GitHub, but the easiest way is just to get it through GetIt, and it installs the test suite as well. So you don't need to actually install the test suite, but you can at least go take a look at it if you want to see the test suite and get an idea of what some of the features it can do from there. But the easiest way is just go through GetIt and then look in your catalog repository folder, and you can find Abbrevia and all the test suite. It's really easy to work with. So the question here, if all the algorithms in Abbrevia are royalty-free. As far as I know, they're all royalty-free, but saying that is potentially a new patent could show up that someone was not aware of that could encumber those. But as far as I know, they are royalty-free for now. And sorry, there was a bit of wondering what segment the audio got kind of.
Yeah, I don't know. It could have been on my side. Maybe one of my servers was using a bandwidth temporarily. I'm not sure. I apologize.
I think it was just that one clip. I think it was only happening during the encoding process. I'll see if I can fix it for the replay.
Oh, okay. All right. I thought.
And so there's a question here of why the REST client components don't decompress responses on its own. So I actually am not sure on that, if that's going to be fixed or added or whatever. I actually have put in a feature request in on that and I'll talk to product management. There might be something I'm not aware of, or maybe it does it and I just didn't know how to do it right on its own. But anyway, at least it shows you how to use those compression streams in that sample. And so yeah, it could be, like I said, if nothing else, it is a feature request, and we'll hopefully see that in the future. Either way. So, and same thing with the being able to modify the response stream. I guess the idea behind the response stream not being modifiable is that it's a encapsulation, right? So the idea is that the REST client and REST request should be the one populating that, and you shouldn't be populating that. If you're populating that, then you're changing the behavior. But when the fact that it doesn't decompress itself on its own, then you kind of need to change the behavior. So yeah, I see the point, and I put that in my feature request as well, because I think it should be. Personally, I like to be able to get inside and tweak things in other libraries and components and stuff, but I understand that the philosophy of encapsulation and such to keep developers out of things. So yeah, either way.
I just wanted to say over on your install, when you install Rad Studio, it's in Documents, Embarcadero Studio, in the case of 10 Seattle, 17.0, then you'll see Catalog Repository. So in my case, I have beacon fence showing up so far.
Yep.
At least on my home computer versus my development machine. Oh, Eric's going, how do I get to the GetIt page? Tools, GetIt Package Manager. Let me go back to my IDE, hit close. So tools, started in XE8, so there it is, tools, GetIt Package Manager. And you're there.
Yeah, and that's it started in XE8, but was really expanded on in Seattle.
Yeah, you have all new filter category things going on. Yeah, it's not hard, just kind of click and.
The thing that's cool about GetIt is you can come. Let's say you're working on a project that uses Lockbox. You come in here and say install Lockbox, and it just takes like a minute or a few seconds, depending on your internet speed, to download that and install it. And then when you're done, let's say you need to use a different version of Lockbox, or you don't want Lockbox installed anymore, or for whatever reason, you come in here and say uninstall, and bloop, bloop, it just uninstalls Lockbox, and it's back to the way it was. So it makes it so that you don't have to have hundreds of thousands of component libraries installed. You just install the ones you're working with, and then uninstall them when you're done. And so, and like I said, we're expanding this, and you're going to see more and more stuff available to GetIt in the future. Although it's already got a great library in there as well. So certainly come and keep an eye on.
Okay, Jim. Great job.
Thank you. Thanks everyone for joining us.
Yeah, we'll see everybody next Tuesday for Delphi. Every Thursday, C++. Same topic each week, different language.